Alright, welcome back to the Maker Show. Today I'm going to go ahead and introduce Circuit Maker. This is the package I'm going to be using going forward on this channel, and you'll soon realize why I'm doing this. It's made by Altium. It's basically the #1 leader in circuit board design programs. Ultima Designer is one of the top programs for doing projects. Now I've downloaded the software, and this is a cloud-based program. So when it loads up, it's going to ask you to sign in. I think I've already put my username and password in here and stored it, so it comes right up. Okay, so these are the projects I've been working on right here. We got the 8x8 RGB matrix tester, the 8x8 RGB cube, then my large format 3D printer program, as well as the master board for that. This is the slave board, and this is the master board for that large format 3D printer board. So I got those pretty much designed. I have to do a little bit more work on them. The boards themselves, upgrading some of the trace sizes on some of the higher draw components. What we're going to do today is actually going to create a new project. So I'm going to go to Home, and I'm going to add a new project. And the new project name is SMD Reflow Oven. And you have a choice of making it public or doing it in the sandbox, basically in private. I believe you're only allowed 2 sandbox projects at any one time. I don't really care. I make pretty much all mine public anyways. So I'm going to go ahead and do, this is going to be the control for SMD Reflow Oven. And you're going to go ahead and hit save. And that's going to open this program for you, this project. So you can put a main image in here. I probably will add an image of the SMD oven. I do. You can also add images of like PDFs and that sort of thing, so you can add multiple programs. I believe there's even a way to add project files like Arduino code and that sort of thing. I haven't looked into that a lot, but I'm pretty sure that is available. So right now we're just at the concept of this, which is totally correct. Just getting going on this. So what I'm going to go ahead and do is I'm on the project right now. We'll just go ahead and save that because I'm in edit project right now. Okay, so I'm going to open the design. Takes just a moment. The speed of the program matters how fast your internet connection is. I have a pretty fast cable connection, so it's not usually that much of a big deal. So this is what it labels the project. Basically project PCB. Now I'm going to go to project, and I'm going to add a new schematic. And I like changing the name of this to the name of the project. So I'm just going to go SMD Oven. Click OK. Okay, so this is going to be your schematic right here, and we're going to go and add some components to it that I know we need. So when I hit place component, this box comes up here. I don't remember which one this is, but it was in my favorites library. So if you hit choose, okay, and this is the window that's coming up. Now these are all the parts I've added for other boards that I've already built. Let me go ahead and find the Arduino. This is the Arduino Nano, pretty sure. Yeah, that's it. So we're going to double click on it. Hit OK. Hit OK there. And we're just going to go right on the board and insert it. Right click and then cancel, and you got your component there. Now it gives a generic designation, so what I'm going to go ahead and do is I'm going to double click into that part, and this is the properties of that part. I just change that to 1. You can see it's a Nano 3.0 Atmel Mega. That's exactly what we want. You can see the footprint right here is basically a bunch of pins, and that's exactly what a Nano was. So that's good. So I'm going to go ahead and click OK, and you can see right down here it says Arduino. Up there I changed it to IC1 now, and you can just start making connections to this, and you're good to go. So the other thing that was in the design was the thermocouple amplifier. So I don't have that part in here, so I'm going to go ahead and go to Home, and then I'm going to go to Components, and then we'll start off in All Components, and we're just going to search for it, and that's an 8595. And it looks like we came up with a bunch of them here. So we can see this will be the symbol that we're going to have on our schematic, and this is the actual footprint that it's going to choose for that. So that one looks fine, and boy, these are pricey little chips. I was looking on Amazon, and there wasn't a cheap chip on there for this particular package. It was they were between $20 and $40 a chip. Buying from China, I got them for down to about $10 a chip, but although I was ordering from China, so just in case one was bad or I made one fail, then I'd have a backup. So I got 2 basically for half price, and you can see that this has up-to-date pricing on what these run, and you can go ahead and use these as prices in your design, although I've found them to be a tad bit on the high price, but these I believe are updated in real time. So I mean, if you're going to DigiKey, you know, they got 856 of them in stock right now. I haven't double checked that with the site, see whether that's the actual case, but that's pretty cool. So we're going to go ahead and add that to our favorites library. Alright, so then we can go ahead and click on it, I believe, or let's go back to our schematic, and we'll go ahead and hit component, and then choose, and then this one should be right at the bottom there because it was just added. And there we go. So we're going to go OK and OK, and we're going to place that right on our schematic. Okay, now what I do, what I've been doing is I will find a YouTube project, basically on YouTube, and then somewhat reverse engineer it, somewhat use what they've done. I like to actually make PC boards. This one I'm going to actually experiment on trying to make it a single-sided board, so that I can go ahead and etch it at home and not have to worry about sending this out to a board factory. I think the density is low enough. This is really good to. It's got wide spacings. It's on 0.1 inch spacings, so there's a lot of space to route lines through and stuff. This is another feature. If you just hover over it, it will give you up-to-date pricing on the part as well. So they say that, you know, those are $21. I wouldn't pay $21. I'd buy it from China for probably about $2 a board, so about a tenth the cost. So you could probably put real price updates in for what you want or what you found, and add that custom information into the BOM of the program, the bill of materials. That's a real good early primer on how to select chips and start a project and start on the schematic. One thing I will show you is we're going to go ahead and select add a PC board. So we're going to go ahead and call that PC board SMD oven as well. Okay, so this is all, I'm going to zoom out a little bit. Page in and page up zooms in, page down zooms out. And home will home it over your cursor. So now you say, okay, where's my components that are on my schematic? So what you're going to do is go up to Project, and you're going to import changes, and it's going to find those ICs right there, and I'm going to go ahead and execute the changes, and it's going to go ahead and place them onto my PC board. So then it's a real easy process of just placing these chips. And if I had connections on the schematic board, there would be rat's nest lines for the connections. So you can see real easy to get a component, get it put on the board, get it onto a PC board, and start placing it. One of the things I found was a little hard was sizing this board to a known size. You pretty much have to go ahead and do like a tape measure like this, and then put it out to the measurement you want, and then go ahead and make the box that size. So I wish there was just a command. You said board be, 900 millimeters by 900 millimeters, and it would just do it. Unfortunately, that's not the case. Natively, this is actually in American or English in mils, so a millionth of an inch. Basically, it has a snap grid up here and stuff. So I'll bring you in later when I got a little bit more done on the board and show you how to show you the progress of it. For now, thanks for watching, and please rate, comment, surprise, and for sure download Circuit Maker 1.3, and you can follow along on my progress on the board. I'll try to make all the projects public, and there's a good way to work on it with me if you want to add designs or take up some of the slack and help me produce some boards. So that's really cool. It's real interactive and community based. So again, my name is Jeff Krupke, and this is the Maker Show, and please rate, comment, and subscribe. Thanks a lot.